Hey everybody, what's going on? Today, on this nice Saturday, beautiful Saturday, we are going to take a look at how my log splitter works for hydraulics. Should be pretty cool. My daughter, she's on the swing over there. Say hi, Charlie. Hi, there she is. And yeah, so we'll go through that. We'll figure out how a hydraulic log splitter works. We'll go through all the parts of it, and then maybe we'll do some math about it. So here, let's take a look at the log splitter. So this is my hydraulic log splitter. You can see here, I got some pile of wood, and I'm kind of running low on my wood for the season right there. So we have a number of different parts with this log splitter, so we'll go through them now. So let's back up here to go, so we got the whole thing right there, so we can see this is the splitter. Let's go a little closer. All right, so right over here, this is the piston that basically forces this wedge through a log. Pretty simple. This is the valving up here, levered forward, pushes that wedge through, back for the return, and it'll actually go back and then it'll click and send that. This is the actual motor itself. So the motor here is connected to the pump. Let's take a look. Here we go. To this pump right over there. Let's get a little closer. There we go, to that pump. That is a two-stage pump. So basically, the output shaft of that motor right there is gonna go into this pump. It's got a set of gears inside that pump right around over here. There's two sets of gears for two stages. It's got one that'll do a high volume of fluid through, but at low pressure, so when the cylinder's retracting. And then there's another set of gears for high pressure. So as that wedge is going through the actual pump, as the wedge is actually going through that wood, there's a valving in there that will basically adjust or send fluid to the high pressure gears. And in those high pressure gears, we'll send fluid out through these lines here into the valving and then into either this port right here or that port right over there. And that'll basically control the action of the splitter. This, it's pretty cool. Down over here is the reservoir. So where the axles are for the wheels is the reservoir for about 3 to 4 gallons of hydraulic fluid. So that's the basics. I'm gonna go through it one more time, but let me set up the tripod and then we'll go from there. All right, so we'll run through that one more time. Basically what's gonna happen is that a log will be placed up on here, like this one. There you go, place the log right up on top. This valve right here, this directional valve, will control the fluid. The fluid inside here, so if I push this way, fluid is gonna get sent down through this tubing into here and push that, fill this cylinder up with hydraulic fluid. And as it does that, it's gonna push this piston out with the wedge into this and split it. When it gets to the end of its stroke, it's gonna wanna return back. So we push the valve this way. It now will send fluid into this portion, filling up the piston this way, pulling the fluid out from here, down, through this pipe that's back here, and into the reservoir here. And that's it. It's pretty straightforward. Push it forward again, push forward like that, fluid comes up, into the valve, down, through here, pushing it back that way. Remember, the purpose of the motor here is the motor, this gas-powered motor, is connected to a pump, a two-stage pump that will basically force about anywhere from like 11 gallons per minute, either causing the cylinder to go that way until it hits this, and then there's a load sensing valve inside the hydraulic pump that will then send fluid to the high pressure gears. And once those high pressure gears engage the fluid, it'll go at like 3 gallons per minute, and then use the torque of the motor to get this cylinder to push through the log. So let's take a look and see how it happens. So that's basically how a hydraulic log splitter works. So we'll go look at the math. We'll go take a look at the math when I get back inside here. So we got a 25-ton log splitter, and we have a 208cc motor. We'll need that information, and I believe it's about 11 to 12 gallons per minute that the pump flows. So let's take a look at the math in there and figure some stuff out.
Okay, everyone, we have a 25-ton splitter. And if we want to calculate to see, is this real or as advertised, we need to know a couple of things. Pressure equals force over area. The pressure we get from the pump. Pump and PSI. The area comes from the cylinder. Right there. And then the force is what's advertised. Okay, so let's go take a look at some of the specs and then we'll go from there. So here's the 25-ton hydraulic splitter. It comes with an 11-gallon per minute low pressure stage pump that runs at 3,000 PSI. So that's our first number. So we go back over to here. So that equals 3,000 pounds per inch squared, which then equals the force over the area. Now the cylinder that is on this, we can go look right over here, is a 4.5 inch by 24 inch stroke cylinder. So this is the actual cylinder. If I had to replace it, you can see the schematic right here. It also tells a maximum working pressure of 3,000 PSI, which is geared for that pump. So let's go over, back. So then that's the area of a cylinder is pi r squared. So then that's pi times 4.5, what did we say, 4.5 inches, so 2.25 inches squared. All right, let's take a look back, make sure we got the right specs. All right, 4.5 inch, perfect. So we go here. Then we need to convert this into an area. So we go to the calculator. Let's just clear all this. Clear. So 2.25 squared, so that's 5.0625 times pi equals, so that's 15.9. So then that's 3,000 PSI. Let's do it over here. 3,000 pounds per inch squared equals force over 15.9 inches squared. We're then going to multiply this times 3,000 PSI. So then 3,000 pounds per inch squared times 15.9 inches squared equals our force. Inches squared crosses out. So let's go back to the calculator. Times 3,000, 2, 3. So we get 47,712 equals our force. 47,712 pounds equals the force, but we need it in tons. So then we are going to go 47,712 times, or that's pounds, times 1 ton per 2,000 pounds, and that equals, so let's take our number, divide by 2,000, and we get 23.85 tons, which is not the advertised 25 tons. So we're actually putting out 23.85 tons on that 25-ton log splitter, pending that the specs that we have are correct, but I'm pretty sure because these are the part numbers that I've looked up and gotten for it. So close, so they round up to 25 tons. Is anyone going to know? Nope, no idea. We can also calculate the cycle time, and we're going to do that in just a second. Okay, so if we wanted to figure out the cycle time of this cylinder, all right, so here's the ram, it's going through, connected to the piston. All right, so we have a 24-inch stroke, so it'll go from here, here, oh, sorry, Let's back that up. 24 inches for that actual piston to move. So from here to there, we know that this diameter is 4.5 inches. So we need to figure out the amount of oil that's going to basically get pumped into this to move that forward. So we can do the area of the circle, so pi r squared, times the length of that cylinder. So we know it's 4.5 inches, or 2.25 inches, times pi, squared, times 24 inches. So if we go to the calculator, let's clear this out. 2.25 squared times pi equals our 15.9, then times 24 inches of travel, so that's 381 inches cubed. There's 231 inches cubed per gallon, because we need to know gallons because our pump is rated in gallons per minute. So then we can basically do 231 inches cubed per gallon. So we could take this number, 381 inches cubed, divided by 231 inches cubed per gallon, and that'll give us our number of gallons. So divide that by 231, and that equals 1.65 gallons. 1.65. Okay, now remember, our pump works at 11 gallons per minute at low pressure. So when it's just moving through. Now to go the pump through the log, so it's 3 gallons per minute through the actual log. So what we're going to do is basically figure out, and that's high pressure. What we'll do is we'll basically figure out how fast it would be if there was no log, and then we could even do it with a log, and then kind of just get an estimate in between. So we have 11 gallons per minute, and we have to move 1.65 gallons. So it's 1.65 gallons times 1 minute per 11 gallons. So we go to the calculator, divide this number by 11, and we get 0.15. So that equals 0.15 minutes. And then we're going to times that by 60 seconds per minute. So we come back, times 60, and that's 9 seconds. So it's 9 seconds for it to travel with no log. Now, what if it's going at 3 gallons per minute, which is trying to force itself through the log? We could do the same math. So then we could do 1.65 gallons times 1 minute per 3 gallons. So let's look at it, clear that. 1.65 divided by 3. So that's 0.55. 5 minutes times 60 seconds per minute, and times 60. So 20 seconds. So this will travel initially from here to here. We would say at 9 seconds, and then the final amount, or when it's going through, would be 20 seconds. Now we don't add them up because some of this travel here is going to be switched. So this cylinder is going to take anywhere from 9 seconds to 20 seconds to cycle through. So you're looking at basically 20 seconds per log. We'll just call it that. So each single log, we're going to go 20 seconds to cycle through. And that's it. I mean, we pretty much figured out that our 25-ton log splitter is not really 25 tons. It's closer to 23 to 24 tons. So it's a little bit of a misnomer. And that the cycle time is 9 seconds to 20 seconds. Now, if we go to the Home Depot site, or the PowerMates site, where it is, it does tell us here it's got a 17-second cycle time with an automatic return. So that's pretty good. We're close. We are math somewhat worked out. Now they're saying 17 seconds because it's going to go this first initial distance pretty quick, and then it's going to slow down at that 20 seconds rate there, or that time there. So that's it. So I hope you enjoyed this. You learned a little bit about log splitters. Stay clean, stay COVID free. Have a good one. Bye.